Okay, so welcome to today's lesson. We are going to be focusing on averages and range again, but we're going to be looking at what we know about the mean, median, mode and range and use this to compare averages now. So we're going to be looking at two different data sets, so it should be quite good fun. And we're going to be looking at the pros and cons of the different types of averages, mean, median and mode, just so you're aware of their limitations. We're going to spend some time looking at some Olympics data. It's a little bit older, it's from 2012, however it should be quite interesting, add some context to what we're doing. And finally there is an exit card, so really important wherever you get to in this lesson, even if you've not finished everything, that you have a go at that exit card and submit it to me on Show My Homework today as the last thing you do in this lesson. So maybe allow 5 to 10 minutes at the end just to go through that. Okay, so the D-Now question is here. We want to find the median of this data. Pause the video to allow you time to work through this. Okay, and the answers are going up now. So what we want to do first, remember, write our list in order of smallest to biggest. Cross off pairs of numbers from either end of the list. And we end up with two pieces of data in the middle. So we've got 10 and 14. Because there are two middle values, we have to find the mean of them. Might be counterintuitive, but that's what we do. So we say the mean of them, add them together, divide them by 2. 12 hours is your mean. Okay, and that means our median is 12 hours. Okay, so we're going to start off by looking at the pros and cons of averages. So what I'd like you to do is work through these examples, pausing the video just so you can have a think and look at the information before I explain. You don't need to make notes at this point. There will be a summary table at the end, which I'd like you to either print off and have a copy with the rest of your notes or copy down onto some paper. Okay, so we're going to start by considering the mean. So I'm going to show you a list of data, and I want you to think what one of the problems with the mean might be if you were to calculate it. So we've got a list of 9 salaries of office workers and their boss, and the list is here. So just pause the video and see if you can work out what might be a problem with this. Okay, so hopefully you've paused the video, you've had a look at the data. So if you were to work out the mean salary of all the 9 office workers, you would get a mean of 11,000. But because their boss is included, who gets paid significantly more than they do, you get a mean of £17,333.33, which doesn't actually represent either the boss's salary or the office workers. So one of the good things about the mean is it uses all of the data, but one of the bad things is it can be affected by extreme values, a bit like this. Okay, so the next example we're going to look at is the median. So we want to consider this next set of data, and we're trying to look to see what problems might be with using the median as an average. For this particular set. So we've got the number of siblings of 7 people. So I just want you to work out the median and then look at the data and see whether you think it fairly represents that information. Pause the video now. Okay, so hopefully you've got a median value of 3. Our data is already in order of smallest to biggest. So if we were going to look at this data, we could say a benefit of the median value is it's not distorted by extreme values, so it's not going to be made too large or too small to represent the data because it sits in the middle. However, if we were to look at the values in our list, there are 2 2s and 2 4s. So it might be fairer to use something like the mode, for example, as a better representation of the number of siblings. One downside then of the median is it doesn't take into account all of the data, only that middle value. Okay, finally the mode. So I'm going to show you 2 examples. So consider this set of data. What's one of the problems with the mode of it? So we've got the marks scored by 10 students in a science test. Just pause the video, have a look and see if you can find the mode and then think about what the problem might be with using this as an average. Okay, so if you look at this data, you will have found quite quickly that there is no mode here. So where there is no kind of mode or value, it does become very hard to say very much about the data. So the second example, we've got a mode with data of people's favourite colour. So can you find the mode from this set of data? Okay, so fairly straightforward. You should be able to see that the mode in that first example is blue. Would you be able to find the mean or median of this data? So just pause the video. Can you find the mean or median of this data? Okay, so I think you'll quite quickly realise that you can't find the mean or median of this data. The reason being is this data isn't numeric, so it makes it very, very hard to put things in order. I mean, you could argue I could put these in order of colours of the rainbow, etc., etc., but actually the fact is it doesn't make any difference. We could put them in any old order, and the averages that we get using mean and median would be meaningless. So we can't find either of these, we would say, from data that categories like this. Okay, so pros and cons of the mode. It's useful if one item appears a lot more than the others. It's the only average you can find for non-numerical data as well, so hair colour or colours like we were looking at before. So non-numerical data, the mode is actually quite useful. And it's not distorted by extreme values, so that one comes up again like it does in quite a few, so it won't be made too large or too small to represent the data. It does use all of the data, so we're looking at everything there. A downside is you can't use it if all the data items are different, or there are lots of groups that are the same. It can be much higher or lower than the bulk of data as well, so you can end up with a mode that doesn't represent. Okay, so this is just a summary of what we've talked through. I would like you to either copy this table down into your book or paper, whatever you're working on, or just have a printed copy there so you've got it to refer to. These are things that you need to be aware of, but we're not going to use heavily in the rest of the lesson. Just pause the video if you need time to copy. Okay, so the main part of this lesson is going to be on comparing data. We want to be able to use these types of averages and the range to compare two different types of data sets. Okay, so in example 1 here, we want to compare the times of two groups of athletes. We've got 19 runners who complete a marathon. In red are the times of the 10 professional athletes in minutes, and in purple are the times of the 9 amateur athletes in minutes. So we want to think about what we could use to compare them mathematically. So just pause the video, think about what we could use to compare them mathematically. Okay, so hopefully you came up with any one of the 4 that we've got. So the mean, median, mode or range could help us to compare them mathematically. So all that means is putting numbers in place of what's going on. So we can say on average this happened with this group, on average this happened with this group. So you might put this into a table. So just think about what you would expect to find with these groups and why. So just pause the video. What would you expect to find and why? Okay, so you may expect that the professional athletes on average are faster than the amateur athletes, and you might perhaps expect that the range of times in the professional athletes group is more consistent than that within the amateur athletes. So what I would like you to do now is pause the video and work out those averages for each group, completing that table in pink in the right hand corner. So just pause the video and complete the table using that data. Okay, so these are the answers. This is what your table should look like. We're going to look later at comparing those averages, but at the moment we're just working on the skill of putting that data into a table. Okay, so another example, just have a go at this question and fill out the table. Pause the video now. Okay, so answers are here. Pause the video so you can mark them, just make sure you've got those scores. Right, so this is the bit where it gets potentially a bit trickier but a bit more interesting. So I want you to think about science lessons where you've done experiments and you've been asked to compare two values. So we're now thinking in sentences about what we can say about the numbers we've got in our table. So in terms of what we could say about the mean, let's look at this first column. We could say something like the mean time taken by amateurs was 159.6 minutes compared to 142.4 minutes by the professionals. So you could just state what you see. You could start by stating those times. Then you might want a conclusion. So the professionals were faster than the amateurs. You want to be talking about what they're doing. So running, those times mean that the professionals on average were faster. So using words like that is important. Median. So we might say the median time taken by the amateurs was 159 minutes compared to 142 minutes by the professionals. Once again, we can conclude that on average, the professionals were faster than the amateurs, and that's fine. We can repeat ourselves when we're making these points. For the mode, there is no mode for either group. Therefore, we could say the mode is not a good average to use because it doesn't tell us anything about our data that's useful. Finally, the range. So this is really, really important. The range is not a type of average. It is a measure of consistency within the data. So the range for the professionals was 25 minutes and the range for amateurs was 43. So a higher number implies that that group is less consistent in terms of their times or their data. So we could say the amateurs had a larger range, 43, than the professionals, which was 25. And the conclusion is that the amateur times varied a lot more than the professionals, who are more consistent runners. Okay, so having a range of 25 minutes compared to 43 means professionals are more consistent. So we want to use that word, more or less consistent. Okay, so key phrases when comparing averages, these would be quite useful for you to have. Pause the video or come back to this slide as you need to. Okay, so now I would like you to go back to that data that you completed in the previous question. I'd like you to write a sentence for each of those rows, so comparing the mean, the median, the mode and the range. Remember, I've given you those sentence starters in the previous slide, so go back and use those if you find that useful. Okay, so writing a sentence comparing, you could have had something like this. So we're looking for keywords like more or less, higher or lower, more consistent, less consistent. Just pause the video if you'd like to compare your answers. So we might look at what's the most useful type of average in this case. Possibly the median, because it takes into account the extreme values of 1 or 2 test scores in English, and it's not so greatly affected by them. You can see when you're looking at averages, you might get some inconsistent conclusions, as with this set of data, and then it's thinking critically about which type of average might be most suitable. Okay, so there are 5 questions. We're going to be looking at Olympic data and comparing the data. So if you are struggling with the sentence writing, please just focus on creating these tables of data and at least getting your numbers there, and maybe come back to writing the sentences at the very end. That's fine. Okay, so just pause the video and mark your answers as appropriate. I've given some example sentences for you. Okay, and question 4, just pause the video as needed. Your table hopefully would have looked like this, and hopefully you've had some sentences that were similar to this. Okay, and question 5, pause the video as needed. Finally, we have our exit question. So we're comparing 2 sets of data of made-up football teams. They've played 10 matches of football each, not against each other, just at all, and their goals scored are below. I want you to draw a table comparing the mean and range of the teams. Part B, what's the highest mean goals scored? And part C, who is the most consistent team and why? So thinking about the range.